This is lesson 102 in Algebra 2, sums of functions as well as products of functions. Alright, when we have a couple of equations, sometimes, if you want to talk about, say, this equation and this equation. Alright, how do I know which one you're talking about here? Well, I can say the equation on the left or the equation on the right, or I can say I'm talking about the equation y equals x plus 3 or the equation y equals x squared minus 6. Well, one of the things about functional notation is it makes it easier to name your functions. So for example, if you remember a while back, instead of using a y, we used an f of x. Okay, so what that means is when we plug a number in here, we're going to get this value. That's what this means. When we plug a number in here, we're going to get a value here dependent on what value we put in here. So depending on the function, depending on the number here that we put in here, we're going to get an answer. If we put a 2 in here, we'd get 2 plus 3 is 5. So f of 2 is 5. And it makes it easier because it says, okay, so if we put 2 in for x, what answer are we going to get? If we put 3 in for x, what kind of answer are we going to get? If we put 0 in for x, what kind of an answer are we going to get? So it tells us what our x is and what our y will be based on what that x is. And it just makes it real handy. Alright, so besides that, it also gives us a chance to name this. So I could call this g of x equals x squared minus 6. Okay? It doesn't matter if this is an f or a g. You're doing the exact same thing. The only thing the f and g does is show you distinction that you're talking about this equation and you're talking about this one. So you don't have to say the equation on the left or the equation on the right. You just say f of x or g of x, and that tells you that which equation you are. That's all the numbers in front of the x do, is tell you, is basically rename the equation. Instead of saying y and y, you're calling it f of x and g of x. It's just giving it a specific name. So if you had 400,000 Smiths in the world, which we'll say are like y's, and you wanted to be specific, you'd give Smith a name like Heinrich. So his name's Heinrich Smith over here, or James Smith over here. So you've just given a specific name to the Smiths. Okay, so it just kind of helps you name which equation you're talking about. That whole Smith thing probably was really complicated, wasn't it? Alright, a couple of the things that we're going to do is when you have a function such as this, you have to tell me what your possible x's can be for this. You might say, which is your domain. Remember your domain? Your domain is what are my possible x's. So if I say my domain are negative integers, that's saying that my only possibility for x's are negative counting numbers. Negative 1, negative 2. I can't use fractions. I can't use positive numbers. So that's just basically giving me a law. I can only use these numbers. Over here, if I said I can use all real numbers, that means my x can be absolutely anything in the whole wide world. Doesn't matter. Okay, except it can't be imaginary numbers because I said real numbers. Alright, so you have to be able to give me a domain. Alright, so let's look at some combinations here of my functions, some of the things that we can do with these functions, if I can get this to erase. Alright, now let's look at an h of x. So this is one equation, and we'll say that's x plus 3. And we'll say that our domain is the set of real numbers. Okay, so x can be any number in the whole history of the universe as long as it's not an imaginary number. Let's use this. That is a Greek letter. I don't even remember the name of it off the top of my head, sorry. Equals, I'm just using the example here in the book. I probably wouldn't have used a Greek letter. All right, and the domain for that, these are the possible x's that we can use here, is the set of integers. So over here, we can use all numbers, positives, negatives, fractions, radicals. Over here, we can only use counting numbers, which basically plot positive and negative and 0. So negative 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. All right, and what they're asking us to do then is to add this to this. Okay, and there are two ways of adding those. Either way works. Not one way is necessarily easier or better than the other. But the way you show that you're adding those functions is we take our h and we add it to that. Okay, so I looked up the Greek letter here, and that Greek letter is written like that and pronounced phi. Okay, so it's just one of the Greek letters, like we have ABC, they have alpha, beta, etc. So that's the letter phi. So if I want to add those two functions, I take my function h plus my function phi, and I put an x there. And that shows me that I want to add those two functions. Okay, so one of the things that's very important when you add functions is you have to look at the domains. Okay, the domain that is all-inclusive is the one that's going to work here. And what I mean by that is, let's say this domain here is a set of real numbers. That means I can have all of my numbers in the whole history of the universe. Over here I can have my negatives, I can have 0, I can have my positive counting numbers. Okay, over here I can have like the square root of 3, I can have 4/3, I can have pi, I can have a bunch of different options here, but over here I can't. So what I have to do is I have to limit the possible numbers that I can plug in here for these x's on which of these is the smallest. This encompasses the smallest group of numbers, right? Just the counting numbers. This one includes all of the counting numbers plus a bunch of extra. So what I can do is I look at this, and it's real numbers. That is a huge, huge set. This here is just integers. This set is smaller. So that's the only set that I can use answers for. So once I add these two, I can only use integers in my solution. I can't use real numbers because integers is a smaller set than the real numbers. Okay, so just to remember that. All right, so how do I add these two? Okay, like I say, there's two ways. I can go x plus 3, which is my h, and then I can do my x squared minus 6, which is my phi. So I've got x cubed, or I'm sorry, not x cubed, x squared plus x plus 3. So I took negative 6 plus 3, that should be a negative 3. And there was nothing to add this x to, nothing to add that to. So my h plus phi of x is x squared plus 3 minus 3. Okay? Then, what it's asking me to do in this question is, what is the answer to h plus phi if I put 2 in for x? So that would be 2 squared plus, whoops, this is an x here. Why did I put a 3 there? Plus 2 minus 3. So that's going to give me 4 plus 2 is 6, minus 3 is 3. Okay, so h plus phi of 2 equals 3. All right, so see what I did there? All I did was took this here and added this here and got this here. Then I put the 2 in for the x, so 2 squared plus 2 minus 3, and that gave me 3. That's one way of doing it. Let's look at another way of doing this one. Okay, so again, here's my h, here's my phi. Alright, and we are looking for h plus phi if x is 2. So what I can do is I can just take my h of x, and so it's h of 2 because it says put 2 in, and that gives me 5. And my phi of 2 is, put 2 in there, 4 minus 6 is negative 2. Then I take these two and just add them together. And I get 3 there as well. Alright, so either way works. You can take the 2, the h plus phi of 2, and you can put the 2 in here, put the 2 in there, and just add your two answers together. Or you can add these first, and once you get a combined equation, you put 2 in. Now this works because my answer, not my answer, but the number I plugged in was 2. And 2 is both a real number and an integer. So that works. I can put a 2 in. If this were like an imaginary number, I couldn't put it in there because an imaginary number isn't in the domain of real numbers, nor is it in the domain of integers. So I'd have to say the answer is the null set. There's no answer. Okay, because I can't plug an imaginary number in there, because this gives me the rules of which numbers I can plug in. In fact, if it asked me to plug in a 1/2, I couldn't do it. Because remember, 1/2 fits into this set, but 1/2 does not fit into this. It has to fit into both sets in order for you to be able to use it. So if I put a 1/2 in here, h of 1/2, I'd look here and go, yeah, it works here, but no, 1/2 isn't an integer, so I can't do it. So the answer again is the null set. Alright, let's look at the second example here, 102.2, and they give us h of x equals x plus 3, and they give me a domain of real numbers. Then they give me a g of x, and they say that my equation looks like this, and they give me a domain of negative integers. And what they're asking me to do is h plus g. They're asking me to add, and they're saying put 5 in for x. Okay, that all looks well and good, because 5, is it a real number? Yep, it is. Is 5 a negative integer? No, it's not. So because it doesn't, you can't say yes to both of these, the answer is the null set, or you can write it, my empty sets look terrible, or you can write it as this. You cannot give me the answer 0. 0 is an answer. You have to give me this or this to show me that there is no answer. Okay, so that is a key thing. Before you can do any work, make sure the number they're asking you to plug in for x works there and works there. If it doesn't work in both, then you don't have to do it. Alright, we'll finish up with the next video, 102b.